Chapter 6, 6.2a, Transforming Random Variables. So let's look at the example. The Eldorado Community College considers a student to be full-time if he or she is taking between 12 and 18 hours. The number of hours X that a randomly selected Eldorado Community College full-time student is taking in the fall semester has the following distribution. So go ahead and look, the hours and then the probability. Calculate and interpret the mean standard deviation of X. So we did this in the last section. We find the mean, we use the calculator, but we do have to show the first couple of terms. So for mean, you would do 12 times 0.25, that should say 25, and I can't change it though, but that's okay. 0.25 goes right here, plus 13 times 0.1 plus blah, blah, equals 14.65. So I actually put this in the calculator. So look at the previous video if you don't remember, but use one variable stats to find those values. And then our standard deviation. So you don't have to find variance first. We only need standard deviation. So standard deviation is the square root of the difference between the X value and our mean squared times our probability. So we show just two terms and put the dot, 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 and get the value from our calculator, 2.056 hours. So we do need to interpret it. So here's the interpretation. If we randomly select many students, the average number of hours taken is approximately 14.65 hours. The number of hours taken by students typically varies from the mean by 2.056 hours. Go to the next slide. At Eldorado Community College, the tuition for full-time students is $50 per hour. So if T equals tuition charge for a randomly selected full-time student, then we would have T equals 50x. Here's the probability distribution for T. So it's the same data. They just changed from tuition hours or tuition number of hours to the charge. So it's like 12 times 50 to get these values. So then to find the mean and standard deviation, we do the same thing. You do have to show it, but right now I'm just giving you the mean and standard deviation from the calculator. But if this were on a free response, you would definitely want to show that to get full credit. So here is our mean, and here's our standard deviation. Notice that this changed to T instead of the previous one where we had X. And we do need to interpret. So if we randomly select many students, the average tuition paid is approximately $732.50. The tuition paid by students typically varies from the mean by $102.80. So it did change because now we're talking about money instead of just hours. So what effect does multiplying and dividing a random variable by a constant have? So we multiplied by 50. So we need to look at how it changed our mean and our standard deviation. So let's look at the next slide. Here is the shape for a number of hours and the center and spread. We had already found this. This is kind of bimodal. It just kind of has an interesting shape. I think it's mainly due because most hours are 3 hours. So 12, 15, 18. So that's why it's like that. Most classes are 3 hours. Here's our center and our spread, which we already found. Here's the shape if we look at tuition charge. So shape doesn't change. Center and spread do. So we'd look at how they change. Well, $50, right? It's changed by multiplying by $50. So its original mean and standard deviation just multiplied by 50. And they were both multiplied by 50. So if we looked at where this histogram would be, it would just be moved to the right. All right, let's look at the next one. In addition to tuition charges, each full-time student at Eldorado Community College is assessed student period 4 fees of $100 per semester. If C is the overall cost for a randomly selected full-time student, then we could write the equation as C is 100 plus the tuition. Here's the probability distribution for C. So we just increased each of our tuition by $100. Probability still stayed the same. Let's calculate the mean and standard deviation. We could use our calculator to do that. Okay, did the standard deviation change? It did not. But did the mean change? It did. So the shape is unchanged. So all it was just moved to the right. The center, which is our mean, it was just added by 100. So it was 732.50, now it's 832.50. So the center was increased by 100, but standard deviation did not change by adding a constant. Do you remember learning about this in a previous chapter? We dealt with Fahrenheit and Celsius. We talked about mean and standard deviation changing. Okay, let's go to our last problem. Linear transformations. Let's go ahead and figure out what all changes. So if y is a linear transformation of x, then the shape is going to stay the same as long as b is greater than 0. So probability distribution of y has the same shape as x if b is greater than 0. The center is going to be changed by multiplying and by adding. So b and a are constants. So multiplying and adding change the center. But standard deviation, our spread, it only changes by multiplying. Adding does not change standard deviation. So we're going to multiply by b, whatever b is. And it has absolute value bars because if we want to make sure it's multiplied by a positive b, because it wouldn't change with negatives. All right, now our last example. Scaling a test. In a large introductory statistics class, the distribution of x equaled raw scores of a test was approximately normally distributed with a mean of 17.2, standard deviation of 3.8. The professor decides to scale the scores by multiplying the raw scores by 4 and adding 10. Define the random variable y to be the scaled score of a randomly selected student from this class. Find the mean and standard deviation of y. Okay, so y is going to be whenever you multiply all the x values by 4 and add 10. So for the mean, we would do just that. We would plug in the mean here. So 4 times 17.2 and add 10 to it. So the new mean is 78.8. So the mean is changed by multiplying and adding. But standard deviation is not changed by adding, so we only multiply to get our new standard deviation. So we are going to use this mean and this standard deviation to find the probability that a randomly selected student has a scaled test score of at least 90. So let's write down what that means. So here is our drawing of it. So make sure you write in and then our mean and standard deviation. And then draw our normal distribution with mean in the middle. And if we want y to be 90 should really be down here. I don't like it up there. It should be down here. We are going to shade above because it says at least 90. So it's right around here. And make sure to label scale test score. And we want to find what the probability is, which is the area under the curve. So we can use Desmos or we can use our calculator. Here is what we're looking for. Probability that y is greater than or equal to 90. So we could use that in Desmos. Or in the calculator, we can go to normal CDF. 90 is our lower. It goes up to infinity, so we can put 10,000. Here's our mean and standard deviation. We're going to calculate it in 0.231. We do need to write this in words. So there is about a 23% chance that a randomly selected student will have a scaled score of at least 90. So that is answering our question, was the probability. And you can use calculator or Desmos. That is it for our notes.